Okay, let's find the matrix M. So we are given this problem where M is a 3 by 3 real matrix, and we know that e raised to the power of m theta is equal to a specific 3 by 3 matrix. You can see that matrix there on the screen. It has cos theta and sin theta in the top left 2 by 2 block with a minus sin theta and cos theta below, and then zeros elsewhere except for a 1 in the bottom right corner. Here theta is just a real number. Now the problem gives us 4 possible options for what this matrix M could be. We need to figure out which one of these 4 matrices is the correct M. You can see the 4 options listed here. They are all 3 by 3 matrices with specific entries. Okay, let's look at the solution approach. We have given that f of theta is a matrix exponential e to the power of m theta. A key property of matrix exponentials is that the derivative of e to the m theta with respect to theta is simply m times e to the m theta. If we evaluate this derivative specifically at theta equals 0, the e to the m theta term reduces to the identity matrix, leaving us directly with m. So our strategy is straightforward. We find m by taking the derivative of the given f of theta with respect to theta and then setting theta equal to 0. So let's start with step 1. Define the given matrix exponential. We'll call the given matrix function f of theta. And as we saw, f of theta, which is e to the power of m theta, is this 3 by 3 matrix with cos theta sin theta 0 in the first row minus sin theta cos theta 0 in the second row and 0 0 1 in the third row. Step 2 is to differentiate f of theta with respect to theta. We do this by differentiating each entry of the matrix individually. So we take the derivative with respect to theta of our matrix f of theta. This means we'll take the derivative of cos theta, the derivative of sin theta, the derivative of 0 and so on for every entry. Taking the derivatives, the derivative of cos theta is minus sin theta, the derivative of sin theta is cos theta, the derivative of 0 is 0. The derivative of minus sin theta is minus cos theta. The derivative of cos theta is minus sin theta. The derivative of 0 is 0. And in the bottom row, the derivatives of 0, 0 and 1 are all 0. So the resulting differentiated matrix is minus sin theta cos theta 0 in the first row, minus cos theta minus sin theta 0 in the second row and 0, 0, 0 in the third row. Now step 3, evaluate the derivative at theta equals 0. Remember our strategy, m is equal to the derivative of f of theta evaluated at theta equals 0. So we substitute theta equals 0 into the matrix we just found in step 2. This gives us minus sine of 0 cos of 0 0 in the first row, minus cos of 0 minus sine of 0 0 in the second row and 0 0 in the third row. Now we know that sine of 0 is 0 and cos of 0 is 1. Plugging these values in the matrix becomes minus 0 1 0 in the first row, minus 1 minus 0 0 in the second row and 0 0 0 in the third row. Simplifying this, we get the matrix M as 0 1 0 in the first row, minus 1 0 0 in the second row and 0 0 in the third row. Finally, step 4. We compare our result with the options given earlier. Our calculated matrix M is this one with 0 1 0 in the first row, minus 1 0 0 in the second row and 0 0 0 in the third row. Let's look at the options again. Option 1 is different. Option 2 is 0 1 0 minus 1 0 0 0 0. Hey, that matches exactly what we found. Option 3 is different. And option 4 is also different. So our calculated matrix M matches option number 2. In conclusion, we found that the matrix M is the one with 0 1 0 in the first row, minus 1 0 0 in the second row and 0 0 0 in the third row. And that matches the second option provided.